Okay, so we're now recording, and the outline for today is to go over practice problems for several of the different concepts that we've covered so far, namely insurance or I guess it's more so expected utility with insurance kind of in the context of that. We want to talk about market demand, taxes, and elasticity. So there's a lot of different questions that we want to get to today. So I'm going to be drawing a lot from our problem sets and our extra problem sets. So if you guys want to follow along, you guys are more than welcome to. But otherwise, I will try to do my best to just make sure that everything is on the board and you can get a full understanding just based off of what I have. So with that being said, I think that what I want to do is I want to start off with extra problem set 5. And there's some very good expected utility questions here that I think would be of use for you guys. So extra problem set 5, and this is going to be question 8, right? And so we're going to just go ahead and get right into it. We're told that this person's utility with respect to consumption is the square root of consumption. And we are told that in the good state, so his consumption in the good state is equal to 16 million. And we're told that his consumption in the should be bad state, his consumption in the bad state is equal to 10,000. And we're told that the probability of the accident occurring is going to be 10%. And so what I want to ask you guys is, what is the expected utility equation that we're going to kind of get out of this? So if I say expected utility equals and then blank, does anybody want to help me out with this? So what I'm asking for is the structure of the expected utility equation. All right. Does anybody want to kind of be brave and step up?
Is it the probability of the accident happening times the utility without insurance, and then plus?
So yeah, in this case, this isn't an insurance related question, but I think what you're trying to get at is utility when you're in the bad state. Is that kind of what you're?
Oh yeah.
Yeah. So consumption in the good state or bad state. Oops, just flip that around. And then what is the rest of the equation?
And then you add the probability of the accident not happening times the utility of consumption in good state.
Perfect, right? And so we see that we basically have all of the information here. The thing that people tend to forget is that you want to include the utility of their consumption. We don't want to just have their consumption. We want to see the kind of, I guess, the happiness that is derived from consuming in that state. And so now that we've set up the equation, right, we have all the pieces to kind of fill in everything, right? So we have 0.1 square root of 10,000 plus 0.9 square root of 16 million, right? And when we evaluate this, this is 0.1 times, I believe this is 100. Could be wrong. It's a good thing to have a calculator. So 10,000, yeah, times that's equal to 100 plus 0.9 times the square root of 16 million, which is going to be equal to 4,000, right? And so this ends up being 3610, right? So what we mean by this is that on average, right, this consumer can expect to have a utility of 3,610, right? And this number by itself doesn't really mean a whole lot, but we'll see in future questions that we can use this expected utility and compare it to the expected utility in different situations. Okay. So this was kind of a softball that is hopefully getting you guys into the right mindsets. The next question that I want to go over is question 9 from the same problem sets. And of course, if you guys have any questions, definitely don't be afraid to kind of just speak up and ask, or leave it in the chat. I think it's a good time to ask questions when there's really nothing on the line. Okay, so we covered this question. The next question is going to be a very similar one, except there's going to be a little bit more nuance to it. So we're told that there is a 50% chance of a rainy season, or I guess on the flip side, there's also a 50% chance that is not a rainy season. We're told that his expected utility is equal to 0.5 times his times the natural log, which is going to be his utility function, right? Times the natural log of his, I guess, crop yield when there's no rain, plus 0.5 times the natural log of his crop yield when there is rain. And we're given that this is how much he is expected to make in each scenario, right? So when there's no rain, he can expect to make 28,000 from wheat and 19,000 from corn. And when there is rain, he can expect to make 10,000 from wheat and 15,000 from corn. Okay. And I want to just kind of briefly examine the expected utility function. And this doesn't necessarily pertain to the question that we have here, because we don't necessarily need to know a lot of the intricacies. We can kind of just plug in some things. But I want to address the fact that when you get this natural log function, this is actually a monotonic transformation of a Cobb-Douglas equation. And I think that somebody in this lecture, I believe it was Malika, she brought up the fact that this is a Cobb-Douglas equation kind of in hiding, right? And you can see this in the MRS, right? The MRS of this expected utility would be equal to 0.5 over y and r over 0.5, right, divided by yr, right? And I'm not sure what I'm doing. Yeah, there we go. And this would actually simplify to yr over y nr, which if you look at the MRS of a Cobb-Douglas equation, right, that is in the form of y nr 0.5 over yr 0.5, right, we would get the same exact MRS here. And the thing that you can notice is that if you were to take the basically the exponential of this whole thing, you would end up with this. And so this is kind of just a cool thing to observe, and it could be useful in the future if you're given this kind of utility function, right? You'd be able to see that you can apply Cobb-Douglas rules to here. But that's all I really wanted to say. I didn't mean to kind of distract from the question at hand, but I do think that it's a very useful piece of information to know. So going back to the problem that we're talking about, we want to see, right, whether we should grow corn or wheat, right? So if we have the decision between growing corn or wheat, which one are we going to choose? And I guess what I want to ask you guys is, how are we going to make that decision, right? What are some things that we can do to determine which crop is going to be better?
Would we find the expected utility if we just grew wheat and then find it if we just grew corn?
Right? Yes. And then we're going to make a comparison between the two, right? And that's where, if you remember, there was an expected utility that we were given in the last question, but we didn't really have much that we could do with it. But in this case, we're going to get expected utilities, but now we're going to be able to make a comparison to another situation and decide which one, right, on average has the better outcome. Okay, so we take a look at the expected utility of wheat, right? And I'm just going to kind of fill this in for you guys, but it's going to be 0.5 times the natural log of 28,000 plus 0.5 times the natural log of 10,000, right? And all of that is equal to, and that's why you're able to use calculators.
So is this kind of like or is this the thing for our bug method?
So in this context, it kind of would be because you're not allowed to kind of split between wheat and corn. So in a way, you have to basically choose from an endpoint, if that makes sense.
Okay.
So it's a very similar kind of thinking, but I wouldn't say that all of these problems are bang for buck.
Okay.
But
I
if it
see,
helps
because
you,
it's asking corn or wheat.
yeah, it's like either or, right? There's no like
Okay.
combination that we can choose.
Thank
Okay.
you.
And so we get that the expected utility of this is 9.725, right? And we want to compare that to the expected utility from growing corn, which is going to be 0.5 times the natural log 19,000 plus 0.5 natural log of 15,000. And we get that this is going to be equal to 9.734. Okay, and so now we can kind of see, right, that on average we would expect corn to provide more utility for us, which is why we're going to want to grow corn as opposed to wheat. All right. So in this case, this person was going to want to grow corn, right? And this correlates to 9.734 utility. And right, the second part of this question is giving us an option to grow half of his field with one of these and then half with the other, meaning that basically half of our field is going to have wheat and half of our field is going to have corn. Does anybody want to tell me what the setup of the expected utility question or expected utility equation is going to be? Right, so my expected utility is going to be equal to what? And if you don't know the entire thing, maybe giving me like bits and pieces so that we can kind of move forward would be good as well.
Would it be the expected utility of half wheat plus the expected utility of half corn?
So tell me what to write.
So it'd be 0.5 times the log of 19,000 for wheat.
Okay, 19,000.
Or not 19,000. Whatever the half of 28 is. I'm blanking right now. But and then you do plus 0.5 the log of 5,000. And then once you find that utility, do you do the same for corn just with half and you add them together? I don't know if that's right, but
so I'm not going to say that that's not the right way to do it. because it could provide the right answer. That's not how I would do it.
Okay.
What I think you should do, right, is, so this is the situation in which we get no rain, right? And we know that when we get no rain, and we have half of our field with corn and we have half of our field with wheat, right? We can expect to consume 19,000 divided by 2 plus 28,000 divided by 2, right? So because they both have 2 in the denominator, we can just write it as this, right? So I think you were on the right track, right? But this right here is our consumption with no rain, right? And I guess I should probably use Y, right? Because this is like the yield that he gets with no rain. Okay. And plus 0.5 times the natural log. And I'm going to just simplify this to 10,000 plus 15,000, so 25,000 over 2. Okay, and this is his yield with rain. Right? So do people understand why you have to, or are people confused about maybe why I chose to have, I guess, a weighted average? Right? Or do people kind of see what's going on here, right? Maybe leave me a thumbs up or a thumbs down. All right, perfect. So I'm seeing some thumbs up. Essentially, and I kind of want to emphasize this, if I were to have half of my field be corn, right, I would expect that when there is no rain, I would get half of 19,000, right, and half of 28,000, right? And this is just a simple way of writing that. But I should note that this is only because we're given the option to grow them half and half, right? Say that I am offered to grow my field with 25% corn and 75% wheat, then I need to account for that, right? And I would multiply 19,000 by 0.25, and I would multiply 28,000 by 0.75. Okay, so it all really just depends on how much of each crop we're going to have, right? But it happens to be 50-50, so we can just divide both by 2. So that's kind of what's going on here, right? And so we get this expected utility function, but we want to see, right, whether it makes more sense to have half of our field be wheat and half corn, or whether we would prefer to just only have corn, right? And so that's why we are going to calculate this out times the natural log of 19,000 plus 20,000 divided by 2. Okay, and we see that this is equal to 9.749. So we actually have a higher expected utility from splitting our field up into half wheat and half corn, right? Because we get a higher expected utility. So this would be, right, what we would prefer to do. Are there any questions about maybe this one in particular? I like this problem because it forces us to really think about what we're actually deriving utility from, right? At the end of the day, we're deriving utility from the expected yield that we are getting in each situation, right? Whether there's no rain or whether there's rain, right? So I think that I've kind of explained this question as much as I possibly could. So I think that it would be in our interest to move on. But if there are questions, feel free to step up and ask or just leave it in the chat. Otherwise, I'm going to erase the board. Okay. And the next question that I want to talk about is question 12. from this problem set. And question 12 focuses on the inclusion of insurance into expected utility. And for those of you guys who may be overwhelmed about insurance, this is the kind of question that you can expect to get, right? Where they are going to ask you for your willingness to pay. That is, that's like a huge buzzword on these midterms. Okay, so in question 12, we're given that this person has a boat, right? Or it's worded as he has a ship, right? And the ship is worth 200 million. And we're told that if he were to get in an accident, the amount of the loss is 200 million, right? So it's going to be the full value of the ship. And we're told that there is a 2% probability that the ship will sink and he'll lose 200 million. We're also given that his wealth is 225 million, meaning that he has 25 million on top of the value of the ship. And we're given that his utility is the square root of wealth. So he's a risk-averse person. And we are asking for the maximum amounts that he would be willing to pay in order to fully insure. So I think that I have a lot of bias because I've seen a lot of questions that are worded like this. So I instinctively know what they're asking. But I want to ask you guys, right? When the question asks you for the willingness to pay for insurance, how do you guys interpret that? Like, what are some ideas that pop into your brain? All right, any takers? So, willingness.
Would we be finding the value K?
So yeah, so in a sense you are, right? But I should note, right, that your willingness to pay for full insurance. So
That
what does
means
that tell
pi
you?
equals gamma,
Could you repeat that?
right? Doesn't that mean pi equals gamma?
So not necessarily, right? Because you can fully assure even without fair insurance. So it's not necessarily true that gamma is going to be equal to pi.
Okay.
But when we have full insurance, there's one thing that's for certain, is that K is going to be equal to L, right? So
Okay, I think that's what I was thinking.
so you're gonna have L dollars worth of insurance, but when you pay for that insurance, are you going to be paying L dollars? And that's a question to anybody. When you pay for insurance, how much do you pay?
You pay gamma or y times L.
Right? You're going to be paying gamma L, right? Because hopefully you're not paying for the full amount of insurance as your premium, right? So what you're paying for full insurance is you're paying the premium, okay? Because think about it, right? In consumption in the good state, you have your starting amounts, and then this is the amount that you actually have to pay to the insurance company, okay? So what we're looking for here is we're looking for gamma L, but we're looking for the maximum amount in which they'd be willing to fully insure, meaning that if it was any higher, then you wouldn't be willing to fully insure anymore. Okay? So, with all of that being said, right, and knowing that we're looking for gamma L, what can we do to kind of get to this last bit?
You can solve for the expected utility of no insurance first, I think.
Yeah, so you want to set up your expected utility with no insurance. And the reason that we do this is similar to the problems that we've done previously, right? We need something to compare full insurance to, right? Because if we actually have more utility from having no insurance than full insurance, right? Then you would just get no insurance and you wouldn't be willing to pay for any insurance, if that makes sense, right? So we basically want to get to that point, that tipping point, if you will, to where if you paid any more than what you're paying, then you'd have no insurance instead because you'd have a higher expected utility. So that's really what it's asking you. So the expected utility, right, and I can kind of just fill this in for you guys, is going to be 0.02 times the utility of consumption in the bad state plus 0.98 times the utility of consumption in the good state. And what is, so I'm going to ask you guys for this, and then from there, I think we should be able to determine this, right? What is my utility of consumption in the bad state? What am I going to replace with that?
It's your wealth minus the loss, so 25 million.
Right, and so is it 25 million or is it a function of 25 million?
Sorry, yeah, it's root 25 million.
Yeah, perfect. Right, so root 25. And I think along similar lines, you can see that your consumption in the good state, right, is if you have no insurance, you're not paying anything to an insurance company, right? So it's just the amount of money that you're starting off with, which is 225. Perfect, right? And you hopefully can see how we have applied insurance kind of principles to our expected utility, right? Because this is consumption in the bad state with no insurance, right? Which is just equal to M minus L, right? And this is really just L, right? So this is really just M, and this is M minus L. Okay, so we get that this is equal to 14.8. So with that being said, how are we going to figure out gamma L? Does anybody want to maybe set up an equation for me that's going to allow us to determine gamma L?
Yeah, there's like a long way, and then I think like the professor did the short way, but the long way would be like setting the expected utility of full insurance equal to 14.8. So
Yeah,
like 14.8 would be on the left side, and then
perfect. I agree with that, right? Because if the expected utility with full insurance is any lower than 14.8, then that means that our insurance cost is too high, right? But if it's higher than 14.8, it means that we would be willing to pay even more for full insurance. And we can see this in just a bit. So this is equal to 0.02 times the square root of M minus gamma L. So 225 minus gamma L plus 0.98 square root of 225 minus gamma L. And because these are like terms, right, we can add the constants together and just get that this is equal to 1 times the square root of 225 minus gamma L. So hopefully you guys can kind of see that the higher gamma L is, the lower my expected utility is going to be, right? Because that takes away from the amount that I can consume in the good state and in the bad state. And basically vice versa for when this is lower. So now we really only have one unknown variable. And so when we set this equal to 14.8, right, we get that gamma L is equal to 225 minus 14.8 squared, which is equal to 5.96, right? So if the cost of my insurance premium is any higher than 5.96, then I am going to have no insurance because I get more utility from there. But if it's any lower than 5.96, right, then that just means I'd be willing to pay up to 5.96. And to something that somebody said earlier, right, we don't have full insurance in this case, but we're still willing to fully insure. Or we don't have fair insurance, but we're still willing to fully insure, right? Because if we know that L is equal to 200, that must mean that gamma is equal to 5.96 divided by 200, which is, so gamma in this case is equal to 0.0298, right? So even though we don't have fair insurance, we're still fully insured, which is something that I want you guys to see, because that reveals to us that when we have risk-averse preferences, that even if we don't have full insurance, we may still want to fully insure. But if we have full insurance or fair insurance, right? So say that gamma is equal to 0.02, then that means that the insurance premium would be 0.02 times 200 equals to 4, and then we would definitely fully insure. So are there any questions about this? I've kind of exhausted these expected utility / insurance questions. So I would love to move on to maybe some market demands / elasticity / tax stuff, if that's okay with you guys. All right, so I'll take that as all good. And so I'm going to skip ahead to problem set 7. So for those following along, this is going to be problem set 7. All right. And we're going to get into a market demand question. So this is going to be question 2. And we have 2 consumers interested in product K. And we're given that consumer 1 has a demand that is equal to Q equals 10 minus P. And consumer 2 has Q equals 30 minus P. And the question is, what is market demand at P equals to 4, 8, and 12? Okay, so who has any ideas about maybe how we can determine these various market demands? There's a few different ways to do it. I kind of want to just preface that.
You just add up their demand functions and plug in the price?
Yeah, so kind of alluding to the fact that there's many ways you can do this. There's one way in which you find the individual demands and you just sum it. So you could plug in 4 right away and then just sum those 2 numbers. Another way that you can do it, right? So say this is Q1 and this is Q2. You would do Q1 plus Q2 equals Q, call it market. And this is equal to 10 minus P plus 30 minus P, right? And this is equal to 40 minus 2P. or actually, my apologies. This should be 30 minus 3p. And so this would be minus 3p. And this is equal to 40 minus 4p, right? And so at each various price, right, you can basically plug this into our market demand. Another way of doing this is if you like seeing it kind of visually, you can plot this down onto a graph, right? So something like this, and then something like this, and you can take a market graph and take a look at each individual price and just, I don't know, figure it out on the graph itself, right? And there's multiple ways in which this question can be addressed to you. They could give you the graphs only, they could give you the equations only, or they could give you both, right? So as mentioned before, there's many ways to do this. So when P is equal to 4, what is Q? And you guys can just kind of quickly read it off to me.
24.
Right, so this is going to be 24. When P is equal to 8, Q is equal to
8.
Right? And when P is equal to 12, Q is equal to
-8.
So that's actually something that I was hoping somebody would bite for this. It's not going to be -8, and the reason why is because you can't have negative demand within the market. So there's going to be a lower bound of 0. So we can't have quantity demanded being any less than 0. And I think that it's a pretty intuitive thought, but a lot of times when you're plugging in numbers, you can kind of just get carried away and forget about the intuition. But I want to remind you guys that whenever you get a negative demand, the lowest possible is just going to be 0. Okay, so this is a market demand question. Hopefully it's pretty straightforward and you guys can see that it's really not too bad. I want to talk about a tax question that is on this same exact midterm, right? And okay, so this is going to be question 3 from the same midterm or same problem set, and I would love to get to the elasticity question that is on the same exact problem set. So we're given D of P equals to 200 minus P, and S of P equals to 3P, right? And what we're asking for is equilibrium P and Q, right? So I'm going to just go ahead and answer this one for you guys. I'm sure that you guys have learned this in just your preliminary econ classes, but when we want to find a equilibrium, all we really need to do is just set these two equal to each other. So 200 minus P equals to 3P, 200 equals 4P, and P equals 50. So Q is equal to 150. Okay, so this is where we start off with. This is 50. Right, so this is where we're starting off, right? This is kind of like the point A on substitution and income effect. It's something that you guys should be able to do kind of just in your sleep. Part B is saying tax of $40 on buyers. All right. So in this case, what is my new equilibrium P and Q going to be? And this one's a little bit trickier, so I want to run through this with you guys. Yeah, so what does this mean for my my like demand and my supply curves? Right? So demand curve is going to shift downwards, right? And how much is it going to shift downwards by? It's going to shift downwards by the amount of the tax, right? So you can imagine if we currently look something like this, right? This is obviously a very loose drawing, right? Our demand curve would go down, and this gap right here would be 40, right? And so just looking at the curves, we should expect that the price is going to be lower, and so is the quantity. So we have this conceptually, but how can we like put it into real tangible values? Well, how about subtracting 40 from here, right? Because if we have a tax of 40, this new point right here is going to be at 160, and the slope is going to be the same, right? So our new demand curve is going to be 160 minus P, right? And so if I were to take these two, I get 160 minus P equals to 3P. 160 equals 4P, and so P is equal to 40, right? And that means that Q is equal to 120, right? So we suspected that both the price and the quantity would be lower, and we were correct. So P is equal to 40, Q equals to 120. And the next question is, what is the change in consumer surplus? All right. And the way that I like to do this is I like to find the original consumer surplus, and then I like to find the new one and just find the difference. I think that that's easiest to me, although similar to a lot of other problems, there's many ways to do this. So, original consumer surplus. Who wants to just real quickly give me what they think it is, right? Or maybe the structure of the equation that we're going to use to find it. All right, well, we know consumer surplus is a triangle, so maybe we can start off with a 1/2. What is the base and what is the height, right? Because that's all we're really looking for. All right. And we're running out of time, so I really would love if someone were to just give me the base real quick.
Would it be 150?
Right? So the base, right, is going to be how many units we sell, right? Because that's going to be the kind of the length of the x-axis. So we have 150 times, and somebody else, please. All right, how about, so you say 50. Nico, could you, or Niku, sorry, I don't know how to pronounce your name, I apologize, but why do you say 50?
Because the first price was 50. So it's like the height of the triangle.
Yeah, that's a good idea, but remember we're talking about consumer surplus here, right? So you would be exactly right if we were talking about supplier surplus or producer surplus, but remember the distance, right, is going to be underneath the demand curve.
Oh yeah, so it's from the demand to 50 then.
Right, so it would be 200 minus 50. So this is also going to be 150, right? And whatever this number is, that's our original CS. And what about our new consumer surplus? Right, I'll help you out. our base is going to be 120, right? And our new height is going to be 160 minus 40. And so it's also going to be 120. Or I meant 160 minus 40. I apologize, right? And I don't want to calculate this, but whatever this difference is going to be the change in our consumer surplus. And the last part I'll kind of just do by myself because I really want to get to elasticity. There's one question, but we're asking for the dead weight loss, right? And so remember, if we were to draw this picture, right? Here's our supply, here's our demand. Demand goes down, right? We have a new equilibrium spot. This amount is tax revenue, and this amount right here is deadweight loss. So we know that the height of our triangle right here, this little wedge, should be the amount of the tax, right? So this is equal to 1/2 times 40. And we also know that the height of the triangle should be the change in the amount of quantity that is exchanged in the market. So we go from exchanging 150 to 120. So this should be a 30 unit difference. And so this is going to be our deadweight loss. All right. So this is kind of what you could expect for a tax question. Hopefully this is all pretty familiar. I think that a lot of this should be like Econ 1 review for you guys. But it's good to just get a problem out of the way. And I'm going to go very quickly for elasticity. But if you guys want to stop me at any points, I encourage that. So we are told that somebody has a demand function of x1 or utility function of x1, x2 being equal to the square root of x1 plus x2, right? And we're told that x1 star is equal to p2 squared over 4p1 squared. And we're also told that her demand for good 2 is equal to m over p2 minus p2 over 4p1, right? And I should kind of just say that on a midterm, I wouldn't be surprised if you're asked to derive your own demand function. So I hope that you guys feel pretty comfortable with that. But this is a question about elasticity, so let's focus on that. And what we're asking is elasticity of good 1 with respect to P1, is it greater than the elasticity of X1 with respect to P2? And for those of you guys who are maybe unfamiliar with this notation, the elasticity is always going to have two inputs. It's going to be the good that we have a demand function for, and then the variable that our demand function is going to be taken with respect to. So as a reminder, the elasticity of X1 with respect to P1 is going to be the derivative of X1 with respect to P1 times P1 over X1, right? And we know what that is. This is going to be equal to, so I personally would bring this to the top, right? This is going to be equal to -2 times P2 squared times P1 -3, all of that over 4. and times P1 over this whole thing, right? And this is actually going to be kind of messy, but this is how a lot of these elasticity questions are, is a lot of just algebraic manipulation. So I think that if you're comfortable with that, you guys should do fine with these questions as long as you remember the structure of the equation. I realize that I'm not going to have enough time to do this one as well, but hopefully this this derivation of the elasticity of x1 with respect to p1 should give you an idea of what this one should be. And I'll just kind of tell you right off the bat that this is not going to be true, because this is going to be a negative number. So this is less than 0, and this is going to be greater than 0. So hopefully you can see that this is true because P2 here is in the numerator. But I might as well finish it. So if you guys want to hang around and watch that, you guys are more than welcome to. But if you have places to go, I understand that as well. Remember, I have drop-in hours if you have any questions. But I'm just going to be kind of posted here until either everyone leaves or until I finish this problem and answer some of your questions. So I'm just going to finish this problem. So this should be P2 squared over 4 P1 squared, right? And I'm going to bring this P1 to the negative third. I'm going to bring that one down, right? And I'm going to cancel, right? I'm going to cancel these P1s. I have a P1 here in the numerator and a P1 here in the denominator. So this should be P1 squared, and this one just becomes 1. And I also noticed that I have, right, a P1 here and a P1 here. And so because I have, I'm dividing by a fraction, what I really could do is multiply by the reciprocal and bring this 4 P1 squared to the top, right? And so now I can cross this out, I can cross this out, I can cross this out, I can cross this out. And so yeah, that's how it's done. You're gonna notice that there's gonna be a lot of elimination that we can do just right off the bat with this. And so yeah, what we get is -2. And the interpretation of this is, for every 1 unit increase in my price, I should expect that my demand for good 1 will decrease by 2 units. So yeah, I apologize that I didn't have enough time to get to everything today, but I do thank you guys for kind of just hanging around. This is more people than I expected would. But yeah, are there any questions about maybe this or anything that I went over today? I realize that this is a long lecture, but yeah, I'm more than happy to explain anything. And I guess I'll maybe stop recording.